A system call is a mechanism that allows user-level applications to request services and resources from the operating system's kernel. It provides a controlled interface between user programs and the core functionalities of the operating system, such as hardware access, process control, and file management. How system calls work. 1. Invocation. A system call is typically invoked by a user program using a high-level API provided by the operating system, such as the C standard library in Unix-like systems. The user program calls a library function, which then issues the appropriate system call. 2. Transition to kernel mode. When a system call is made, the CPU transitions from user mode to kernel mode. This transition is necessary because the kernel has higher privileges and can safely access hardware and critical system resources that user applications cannot. 3. Execution in kernel mode. The operating system's kernel receives the system call request and executes the corresponding service routine. This may involve interacting with hardware, managing memory, or performing other privileged operations. 4. Return to user mode. After the kernel has performed the requested operation, it returns the result to the user program. The CPU then transitions back to user mode, and the user application continues execution. Types of system calls. System calls can be broadly categorized based on the type of service they provide. 1. Process control. Create, fork, exec, terminate, exit, wait, signal, kill. 2. File management. Create, open, read/write, read, write, close, close. Attributes, chmod, chown. 3. Device management. Request, iactl, read/write, read, write. 4. Information maintenance. Get time, get timey off day, get system info, uname, set system info, sethos name. 5. Communication. Message passing, migsend, mscrec, shared memory, shmget, shmat, pipes and sockets, pipe, socket. Example of a system call, read. Here's an example of how a typical system call, read, works in Unix-like operating systems. 1. User program. The user program calls the read function to read data from a file descriptor. Size _ bytes read equals read, file descriptor, buffer, buffer size. 2. Library function. The read function is part of the C standard library. It prepares the system call by setting up the necessary parameters and then invokes the system call using a software interrupt or a special CPU instruction. 3. Kernel execution. The control transfers to the kernel. The kernel identifies the system call number for read, checks the validity of the parameters like file descriptor and buffer, and reads data from the file into the buffer. 4. Return to user mode. The kernel returns the number of bytes read, or an error code, to the user program, and the program continues execution in user mode. Importance of system calls. Abstraction and portability. System calls provide a uniform interface to access hardware and OS services, abstracting the underlying hardware details. This allows applications to be portable across different hardware platforms. Security and stability. By restricting direct access to hardware and critical system resources, system calls enforce security boundaries and protect the system from potentially harmful operations by user programs. Resource management. System calls enable the OS to manage resources like memory, CPU, and I/O devices efficiently, ensuring fair allocation and preventing resource conflicts. Conclusion. System calls are a fundamental part of operating system architecture, enabling user programs to safely and efficiently interact with the hardware and system resources. They encapsulate low-level operations into a set of well-defined, high-level interfaces, providing a bridge between user space and kernel space. The objective of this video was to know about system call.